Okay, I've been asked to talk about the roadmap for green transition in agriculture that we developed last year. It was a collaborative effort with many researchers from many different disciplines and many universities and other organizations in Denmark. Now, the reason why we did this was that we have been we've been challenged with having more mission-oriented research and partnerships between universities, research organizations, industry, and the public sector as well. So the government asked the Innovation Fund Denmark to initiate a process of such mission-driven partnerships. And last year in March to May, we were asked as part of this process to develop a roadmap for, in this case, a climate and eco-friendly agriculture and food production. So this was the background for us, and that was then used as a basis for a call for partnerships later last year. We still don't have that partnership. It's in contract negotiations at the moment. But just to illustrate, when you try to have an overview of the agriculture food system, it is really immensely complicated, as I'm sure you all know. But also comes clearly out when we try to map it. So let me try to illustrate. So on the left, you'd see here we have land use and management, and that is of course the land and how we manage it for food, fiber production, and so on. Of course, impacts what kind of products we can deliver, both directly for plant-based foods, different types of foods that eventually, of course, goes to the consumer. But it's also a question of what we can deliver for feed, for the animal-based production, and of course, in as part of circularity, we have manures and so on coming back to the land. But we're also considering that, of course, we also have other sort of sources for biomass, including aquaculture, but in particular considering the circularity of this and how to further improve things. We're thinking in terms of biorefining and so on that may in other ways provide the inputs also into the future of some more biotech-based solutions for the food production. So that could be cell-based proteins, for instance, cell-based meats. It could be precision fermentation and so on of some milk substitutes and things like that. It's also important that, of course, this agriculture is not sort of there on its own. It's influenced by policy. It's influenced by many different stakeholders, also by the value chain. So we have that at the top of the graph here. And to inform all of those policy stakeholders and so on, of course, accounting for the negative aspects, including greenhouse gas emissions, for instance, of the entire system here is important. And at the bottom, you'd see, of course, it's very important that this is monitorized in some way, because the financial aspects of it and the profitability and so on is extremely important for developing solutions. It's also important to recognize that there are many different sustainability objectives. It's not just environment and climate, it's also biodiversity, pollination, things like this. It's other types of consideration of what land needs to deliver, including also other purposes like nature, like recreation, but also contributing to adaptation for climate and climate change. But not least, of course, having sufficient food supply. Now, Denmark is a food exporting country. We export 70 to 80% of the produce. So if we are to look into what would happen in terms of the global development in food production and food consumption, we expect a 45% increase in food demand by 2050. And we think it would be fair that we keep our proportion of this. So we'd also need to increase food supply by 45%. And then finally, of course, there's the question of jobs and economy and so on as well. Denmark is not as big a country as Finland is, but it is largely agriculture. So that is a big part of it, and it of course is mostly into conventional agriculture, but organic farming has been increasing greatly in recent decades. So it's now about almost 15% of the land area, and you'd see we also have other parts of the land used for other things. But in total, it's about 62% of the land area that is in agriculture. So if we are to look at how we deliver on those sustainability objectives, it is really quite a lot has to do with our land use and management, because that's what in many cases directly affect on these sustainability criteria. So it's about reduced greenhouse gas emissions, it's greater primary production, it's reduced nutrient loads, reduced pesticide use, and greater biodiversity. And we need to look into different aspects of it. It's about changes in the landscape structure, its functions and management, and how we govern all of this so that we facilitate the necessary change. If we look at landscape structure, and that's also illustrated with a map to the lower right, we have, as in Finland, quite a number of wetlands, but many of those wetlands in Denmark have been drained. This has resulted in them being a hotspot for greenhouse gas emissions, in particular CO2, but they have also lost what they had, many of them had previously, as a buffer for nutrient loadings to the aquatic environment. So re-wetting and restoring these lands is about both reducing our greenhouse gas emissions and also reducing nutrient loadings to the aquatic environment. On top of that, we'd like to also make some new wetlands and constructed wetlands, buffer zones and so on, primarily to reduce nitrogen and phosphorus loads, again, to the aquatic environment. We think that would also have the benefit of adding biodiversity. There may be other needs for different types of technologies and so on, in particular for the nitrogen phosphorus retention. We should also look, of course, at measures to reduce nitrous oxide emissions, and something that we think we've been overlooking to a great extent are those parts of the landscape which again are hotspots for this, typically maybe poorly drained mineral soils. Cropping systems is really important, and Pirjo touched upon some of this. But we think we need to look into redesign of a large part of our cropping systems if we are to move towards something that would be moving towards climate neutrality, but also in compliance with many of the other sustainability goals. So for arable cropping systems, it's enhancing the diversity of species in this. It's also looking into how we manage those crops, in particular maybe looking at the harvesting times of this. This is important so that we have the cover crops actually performing much better, and maybe we can also use those not just as a cover crop, but really as more or less as a double cropping system, where those they would also be able to supply biomass, for instance, for the biorefining. Forage cropping systems With the grasslands, we need to move towards multi-species mixtures, and it's not just grass and clover. It would also include various types of forbs, also with flowering species, so that we can also have some of the pollinators back in the landscape. Perennial cropping systems we also think is important, including agroforestry, and it's important because some parts of the landscape we cannot really manage the low nutrient losses or the greenhouse gas emissions with our annual arable-based cropping systems. So there is a need for novel perennial cropping systems. And then on the management side, there's a lot of things that need to go in there, looking at fertilization, precision farming, interactions with the plant breeding, and need really new breeding goals here that looks both at how cultivars do from a performance perspective in the field with these environmental climate aspects, but also looking at quality in the production chain. So I think there's a need for a new paradigm when it comes to plant breeding. Biorefining technologies in order to upcycle biomass for many different purposes. And then we think we cannot solve our targets without also looking at the biochar as part of the energy system to sequester carbon. On top of that, we have governance aspects, and I won't go through this here, but there's really a lot that has to do with documenting various aspects at the landscape scale. Many of these aspects and we don't have the tools really to precisely at farm and field scale to document these many different aspects. There's also, when it comes to biodiversity, nature, and so on, the questions of what do you do with land sparing versus land sharing. We need also to look at how can some of those functions in the part of the landscape that we will no longer use for agriculture, how can we restore natural and dynamic processes in those parts of the landscape. And then, and that also goes with it, there's really a need to support the actors and stakeholders in all of this process so that we can have a speedy process in terms of this transition. And there's also a lot of things that should be done here, not least in terms of how to monitor and sense things. Jörgen, we also need to look at, we also need to look at how nutrients flow in the landscape in terms of where we target things. I won't go into detail of this, but it's really a question of looking at the various functions of the landscape. Now we've looked into what we can do in terms of reducing greenhouse gas emissions here, and this just illustrates how many different sources we really have. And if you look at the total here, the baseline emissions of Danish agriculture is 17 million tons of CO2 per year. It's 35% of total Danish national emissions, so it's really important. And then we've looked into how big a proportion of this do we think, given that we develop technologies and so on, we could reduce by 2030 and 2050. And we do think that in particular, if we also move into adding the carbon sequestration part of things, that we can approach neutrality by 2050. Same thing, we've been looking into what could be done with reducing pesticide use, enhancing biodiversity, and so on. It's different parts, it's different aspects really. So there's a lot of additional thing that needs to be done, but it is also, we think, feasible. But it's of course a tremendous task. So initially I showed this one. So we have those four tracks in here. I've only been explaining about one of them, the land use track. So we have developed also the other parts here. And you're of course welcome to contact me if you want to know more. Circularity, we think, is a really important part of things, because on top of working individually on these different aspects of the landscape, making sure that biomass, nutrients, everything is circulated and there is no waste. Even CO2 is not a waste. Even CO2 is upgraded, for instance, to energy. as an energy carrier. And we believe there's a lot of also potential jobs and profit and so on to be gained here, because we are looking at phasing out fossil fuels and other types of inputs here. So we need to base things on circularity. Now, and this is the last slide, no, second last slide I have here. This really cannot be done without sort of overlooking things from a couple of cross-cutting issues, in particular accounting of emissions. It's greenhouse gas accounting and nutrient leakages accounting and so on. And that all will depend on data. So we need a data-driven agri-food system. And this is, I think, also where we need to come together across countries and across different parts of the globe, because it would be nonsense that we were using this from different sort of perspectives. Many of our companies are multinational, and they need to go dig into the same data-driven system. We also need regulation and incentives right the way from farmers to consumers. And to develop this sort of thing, of course, we need investments. We need to invest in this transition. We need to invest in research and innovation, also the capacity to do it. We need to establish research and innovation partnerships, and we need to fund it all. And it's going to be tremendously expensive. If you want to read more, we've written a white paper on this, and it is available on the website. You can find it here, or you can just Google this roadmap. Then you'd find it. This is all.